Okay, so this is problem 2236. I don't know why I wrote 2236. What we have is an electric field that's pointing just in the z direction. And it's a function of x. So what I've got here is a three-dimensional coordinate system, x, y, and z. And you can see that if I look at the xz plane, the value is going to increase as a function of x. But it's going to be pointing in the z direction. So now as far as a function of y, it's not a function of y, so it's the same at any plane in the perpendicular to the xy plane. So this is how I would represent it as a vector, 964x times k. And because it's perpendicular to the plane that we're interested in, you don't really have to do a dot product because the angle is 90 degrees, so it's just going to be, it's perpendicular to this plane, so it's just a straight calculation. There's no geometry involved. As far as calculating the flux is going to be equal to the electric field times the width in the y direction, so that's this number. And then you have the dx, which takes into account the x direction. So what I've done here is I've taken the 964, which has units of newtons per coulomb meter, and I multiplied it by the 0.350 meters. So I get 337.4 newtons per coulomb times the x coordinate times dx. So it's a real simple integration problem. So when we integrate this, we'll get 337.4 newtons per coulomb, and the integral of x squared dx is x squared over 2, and we evaluate that from x equals 0 to x equals 0.35 meters. So from 0 meters to 0.35 meters. So this is a definite integral. So we plug in the upper limit, which is 0.350 meters. We square that, divide by 2, and subtract 0 meters squared divided by 2. So we get 337.4 times 0.35 squared divided by 2, which is 20.7 Newton meters squared per coulomb. So that is the flux. You remember, flux is basically, if we just do it assuming that it's constant, that the electric field is constant over the area, it's just the electric field times the area, with the electric field having newtons per coulomb and the area being meters squared, so the units make sense. So that's pretty simple, isn't it?